React.js is a JavaScript library for building user interfaces. My guests are Sebastian Markbage and Christopher Chedeau. Sebastian and Christopher, welcome to Software Engineering Daily.
Thank you.
You're welcome.
What is React.js?
So React started as a DOM library for creating these UIs, and it's basically a functional style for generating DOM UIs. And after that, it has grown in scope to also cover native UIs and canvas UIs, and there's even a 3D modeling plugin for it.
How does React.js change how user interfaces are developed?
So the big change is that you write it in the declarative style, but the logic is also declarative to some extent. And that's different from the traditional DOM model, which is totally imperative, where you tweak and change every individual property. But it's also different from other declarative sort of compositing frameworks like Angular or Ember, because it's inside of JavaScript. It's a full-featured general-purpose language. It's not a limited templating language.
And how does React.js make development more modular?
So it's components is a core principle of React. Everything is a component, and everything becomes modular by encouraging all the logic to be encapsulated into components. And the way that happens is by exposing a tight contract. So this is different between, for example, inheritance, because inheritance doesn't allow you to really constrain the API. You can't limit the API of when you inherit something. But where a component and composition allows you to create a wrapper that uses the internals of another component, but exposes a more limited set of attributes or configurations.
How does this differ from the pre-existing front-end solutions that were around when React.js was first created?
So there was a number of frameworks at the time. There was the more traditional imperative style frameworks, and they're also very much in retained mode, where the state lives in the DOM. So jQuery is one example of this, where you associate a lot of what your business logic is with the DOM element and the instance in the DOM itself. So that has some issues. And then there's other frameworks like Ember and Angular. The main issue there is how they constructed the declarative frameworks that suffered a lot of performance. So they've become much better since then by following sort of the lead of React in terms of how you create declarative frameworks in a performant way.
Modern web development design patterns include model view controller, model view model, and then so on, all kinds of other acronyms. Does React have an opinion on how we should think about these patterns?
Well, so we used to say that React was the view in the MVC or the view in the MVVM. But so that allows you to sort of build your controlling system and your model system around the React, and then have React just be one part of your stack. However, as we're building more and more apps with React and expanding what the component is and how we encapsulate more and more components, it's become clear that what used to be a controller no longer really has any place. And what used to be a view model is more tightly coupled to what is the view, because the view model in the MVVM model is really, when you change the view model, you also change the view. There's no changing one without the other, really. So we think that they should be sort of encapsulated in a controller. That logic is really what the view model was supposed to follow as well. Then we have the model, and usually when you create a simple React application, the model is really just some JSON-like data or a simple to plain JavaScript object, and you can update that, or it could be an immutable data structure that you put inside your state. But then, as you keep growing and expanding, you end up with a more complex model tree, and that's where Flux comes in, or similar frameworks built on top of the idea of Flux, which is a different kind of way of thinking about the model.
Right. So models are at the heart of these frameworks, that's a quote I took from a talk that I watched about React. So the presenter defined a model as, quote, an observable object. And he said that in modern web development, quote, an object has an event API. How should developers think about the relationships between these three words, model, object, and event?
So one way to think about, if you think about the model and the traditional imperative API, the event is usually tightly coupled with the model. It's essentially a mutation. When you change the property on an object, there's an event that spins off of that. That's sort of the notion around an observable object. But what React does is sort of put that on its head a bit and say that actually we don't change and mutate the objects directly. What we do is we send out the message, this is the event part of the system, to what we call a dispatcher, or something like it, or a callback upwards in the tree. So the changes doesn't happen on the object itself. It gets sent to this centralized place, and the centralized store system that the dispatcher can then determine what changes should happen. And those changes may or may not be a direct manipulation of the object. But so, for example, in an immutable data structure tree is something like an immutable Flux system. You wouldn't directly mutate the object. You would create a new object tree that has the new set of changes applied to it.
When React.js got started, what was the state of web development at Facebook?
So most of Facebook development was server side. There was also a large client side development happening on two fronts. One is the native apps, which is basically our main consumer facing apps. There was also a large client side development happening in our business interfaces, because they were having really complex and interactive UIs to create ads on Facebook or something like this, and manage your page on Facebook. But most of it was actually server-side driven, using a version of PHP, sort of a fork of PHP that we had. But then we also had multiple client-side frameworks to handle this, and they looked similar to what was else outside in open source land. We had one that was fairly heavily inspired by SparkCore and Ember. But none of them were really, there was a lot of complexity in it. So this guy called Jordan Watt, he was kind of fed up with that, and he figured that it should be more like the server-side rendering that he saw that we had in PHP that we had developed for many years before. And I figured that, well, it should just be as easy as refreshing the page or generating a new page every time. And that's sort of what that created the idea of React. But then at the same time, there was also this project to rewrite the Messenger app, the chat interface. And that had really a lot of problems around data flow, which is sort of around this idea of Flux. But it was missing a toolkit for generating UIs from this data flow. So they had already solved the data flow problem by reconstructing and rebuilding the domain model for Messenger. But then they needed a way to visualize it and build a UI around that. And React became one of the tools for building that. So that was one of the early projects. I
find that. Sorry to interrupt. Well, let's go ahead. So, yeah, I find that interesting because it sounds like Messenger was a template for other things developed in React, which would be interesting because Messenger is sort of like a de facto real-time app, and that's basically the way everything else in the web is going.
Yeah, so that's one of the interfaces, but then there was also another interesting project happening at the time. We were building out Instagram Web. This was right after Facebook acquired Instagram, and Pete Hunt was building the Instagram website. So he saw React and figured this is a really good way to build client-side UIs. So he started building the entire website that way. But the Instagram web isn't really a production environment. All the uploads for Instagram happen on the mobile devices. So the desktop didn't really have this real-time component to it. And it also wasn't really a production component. So he instead focused on a very interesting artifact of the implementation details of React to create server-side rendered React. So that's sort of on the flip side of that UI. At the same time, I was building a new business interface for client-side React or for client-side UIs. And I saw React and I thought, well, this would actually be appropriate for something like D3 or replace D3. So I built out a charting library around that. So there was multiple different use cases all developed at the same time. And another one was for photos. Do you want to...
Yeah, so I think what's interesting about React is like the idea is so good that we were able to build like so many different things on top of it, like the real time with and the data flow with Messenger, all the very complex and like mutation heavy of like the business interfaces, the server-side render with Instagram, like the like photo viewer and everything, and now React Native got us like the native part. And yeah, this is fascinating to me to see that if you start with a good like architecture at the core, then you'll be able to build up like more like better layer on top of it. And I think this is one of the fundamental things that we haven't seen with the web is the web's like before React was like hacks on top of hacks on top of hacks. And I'm really like seeing React as a way to like start afresh and like with a better architecture at the core.
To understand the breakthroughs that React.js makes, we need to discuss the document object model. So let's just start by simply defining what is the DOM.
So the DOM is, I'd say there's two pieces to what people call the DOM. There's the HTML model, the CSS model, the actual sort of the original thing that spawned the web before JavaScript, right? There was a way to render web pages without JavaScript even before JavaScript existed. But then you needed a way to interact with this HTML model from the start. And that became an object-oriented API. And this sort of an implementation detail of how the DOM was built based on, or rather how the HTML was built using C++ data structures. And that those ideas sort of leaked in to create an imperative object-oriented model for manipulating HTML, the underlying implementation of HTML. That was exposed as into JavaScript. So it's really not the entire world. It's really about this object-oriented model for manipulating a document tree. But then there's also not something called CSS which is related to the DOM. It's the same model, but for manipulating the CSS data structures.
How is the DOM stored in memory?
It's basically a C++ class hierarchy implemented in the web browsers. And then JavaScript manipulates that. And the problem with that is JavaScript and C++ have different data models. They have different memory models. And every time you reach from one into the other one, there's some locking, some verification code that has to happen. And there's also a translation between this data model. You can't just pass one data model through into the other world. You have to duplicate the memory model. So there's some overhead of marshalling as well. But then more and more things are sort of coming into the JavaScript world. A lot of what JavaScript is today is implemented in JavaScript itself. But most of what the DOM is still in C++. So one of the things we did with React is realize that actually there's a lot of overhead going back and forth here. So we made a design decision to make a lot of the APIs asynchronous, which is easy when you have a declarative model. And that allows us to batch up a lot of operations and execute them as a unit instead of as individual commands over the bridge.
So what you're saying is one of the breakthroughs of this diffing, the virtual DOM diffing that we're going to get into in a sec. One of the big breakthroughs is that you're able to batch changes, and so that in this period of time that you have to spend on marshalling JavaScript code into essentially C++ code, you can batch that, and so you can basically do one marshalling operation instead of doing n marshalling operations.
Yeah, so this is becoming less of an issue with modern browsers, and especially with Chrome. They've focused a lot on minimizing the overhead of this bridge, and even there was even experiments with them re-implementing part of the DOM in JavaScript to minimize this problem. So that's become, but at the time when we built React, and especially for older browsers like IE8, 9, and so on, that's still a big issue. There's another issue that is related, which is the DOM APIs have synchronous read operations. And if you read something and then write something and then read something, the second read will cause the first write to happen and recalculate a lot of things in the DOM structure itself, for example, layout. So what you really want to do is do all your writes first and then all your reads, instead of doing write, read, write, read, write, read. So another thing that the asynchronous design allows us to do is coordinate between different programmers so that they wouldn't accidentally do a lot of writes and then reads.
Let's discuss the DOM diffing algorithm. Because it's a really interesting piece of engineering, whether you're a front-end developer or just a developer in general. So why don't you start off by describing what is the virtual DOM?
So the virtual DOM, it's kind of a misnomer. People have sometimes mistaken it for being a re-implementation of the DOM, and then something that we use to diff against. But the virtual DOM is really about having a data structure to describe the output. And this data structure is more coming from the functional world, where you describe things as an immutable value type or a immutable tree of properties and so on. This is also slightly different from what other templating frameworks were doing at the time. They were focusing a lot on the traditional server-side model. So coming from the server side, a lot of the MVC frameworks were designed around generating strings, right? Yeah, so the traditional models were sort of ported from the server-side web world, where the PHP and Ruby on Rails were all built around the notion of generating a string that's going to be the output of the document. And then client-side frameworks tended to do the same, where libraries like Ember and I think Angular has the same notion of creating a template that generates a string. That's at least the conceptual model until recently. But what we did at Facebook on the server is, for PHP and our extension XHP, is create data structures and then use those data structures to later generate a string. So the programming model was never about generating a string. It was always about generating data structures. And I think that history is what led us to think similarly about React. And that's what the virtual DOM is. It's about creating these data structures.
Yeah, also one interesting thing about the XHP and the server-side thing, the reason why we generated data structure was for security reason. because there's one big security thing on the internet which is called XSS. And this is when you concatenate strings, you have no idea if the string is part of the markup or is data. And if the data contains markup, like script, eval, or anything like this, then it's going to be executed as such. And it was really hard, like for a developer API to like add like, oh, I want to escape this part because it is data, and I don't want to escape this part because this is markup. And by using data structures, now by default, we're able to say that, oh, this is part of the syntax, so this is markup, and this is a variable, so this is data, and I'm going to escape it by default. And so this removed like an entire class of like security vulnerabilities that were plaguing Facebook at the time. Like it was like 8 years ago or something, like a very long time ago.
Yeah. So I think that our history of designing that framework is sort of what made us go a different route, even on the client. For different reasons, just the programming model is different, is more functional and more declarative. You don't really have to think about the timing of if adding this string now or triggering this command now affects something later. And so that's the virtual DOM. But then the question is, how do you apply this to the actual DOM? And that's where the diffing algorithm comes in. You could say generate another string and first generate the initial string, insert it into the DOM, and then just replace that string or markup or whatever whenever you want to update something. The problem with that is that you blow away a lot of state that is in the tree. Some of that state is important, for example, text contents or scroll position or current selection. You also blow away mem-wise state. So there's a lot of calculations that happen that you don't want to have to redo every time. So the real invention in React is how it took this model, but instead of replacing the string, it took these two data structures and compared each part of the data structure to see what has changed between the old version of it and the new version of it, and then apply that to the existing underlying imperative API. So that also allows us to do the minimal operations we can. It's not always the absolute minimum because there's a trade-off. We do this largely for performance optimizations, and sometimes diffing takes time as well. So there's a trade-off between how much comparison you do versus how many commands you want to apply to the underlying imperative API. But that's the balance that the framework has to walk.
So to get into more about the virtual DOM, so there's an algorithm that is used to find which elements of the user's currently rendered DOM are different from elements of the virtual DOM. And so this algorithm originally took O of n cubed, where n is the number of DOM nodes. And after several iterations of improving the algorithm, the diffing only took O of n, which is a fantastic improvement. But one thing I was curious about when I was reading about this, diffing two trees seems like a fundamental computer science problem. So why wasn't there already a solution to that? So
the solution is, as many times in computer science, is to cheat. It's to figure out that you don't actually have to do all the real, you don't have to have all the constraints of the original problem. There's already existing knowledge in computer science around how you can use immutable data structures to determine that something very deep within it is unchanged. So there's a lot of work from Richicki on Clojure. Another interesting data point is Git, the version control system, where basically you don't have to transfer objects that you are guaranteed to already have. That case, it uses a hash to determine that. But the principle with immutable data structures is that if you have some kind of ID, like a reference or a hash, that tells you that something about the entire subtree of the structure, and you can compare just that ID to learn something about the entire subtree. So one thing that React does pretty frequently is check that if the new subtree and the old subtree have the same identity, then we know that something hasn't changed, so we don't have to walk that tree again at all. So that allows us to cut off a huge subtree of the hierarchy. Another thing that we can do is we actually, because we're in control over where mutations happen through the set state or force update APIs, we know which part of the tree has changed, could have possibly changed its state, and where mutations could have happened. So we can also do deep reconciliation, what we call it. It's basically we skip to a certain point in the tree and start from there. So that allows us to also skip the top. So now we have two techniques for skipping whole leaves trees, but also skip over the root nodes of the tree.
Yeah. One example for this is, let's say you have a button, and when you tap on it, you want to highlight it. So what you can do is you can do set state in the button itself. And because it's only going to re-render like the subtree below the button. So only a few nodes, which is pretty fast. And for like the shoot component update and like the immutable data structure checks, it's, for example, if you have an entire page and you know that it takes its data from like some data source, and this data source is immutable, you can just compare this data source before the old one, and then like remove an entire part of the tree. And so before you mentioned that we started with O of N3, actually like this is not correct. Like we never implemented this because O of N3 like way too slow. So instead we added like one big constraint, which is that we only do a diff on the same level. So this is like limiting the scope a lot. And the reason why we were able to do that is because most of the time when you're working on the UI, you're not moving an element within the hierarchy. You're only moving it between children. And so we found that this was a good compromise that helps performance a lot while still being like useful.
Why is the ability to do server-side rendering relevant to React.js?
So the big shift that has been happening, other than building new libraries in JavaScript, is that we're also moving more and more code as an ecosystem and as an industry to be client-side, because devices are becoming faster, and now it becomes viable to execute a lot more code on the device instead of on servers, which allows you to build very low latency UIs with rich interactions, which is what React allows you to do. However, there's a trade-off to that. You first have to download all this code, but bandwidth is getting better. It still takes some time, but you also have to start up the code, and this code is generally in a scripting form. It's not pre-compiled in an optimized way, so you have to parse it from the original source, and then also have to run it. And the way JavaScript modules generally work is that they're fairly eager in the way they execute. So just warming up and creating code, especially because JavaScript tends to do a lot of meta-programming to even create the runtime. So there's actually a large cost to powering up a client-side JavaScript environment. That means that the initial page load is fairly slow in certain cases if you build a really large tree. It's an area that we're trying to optimize for and like figuring out what we can do. But until then, what server-side rendering allows you to do is execute the first view on the server, send the results of that computation in a smaller format, which is HTML and CSS in this case, to the client, and they see something immediately. It's not immediately interactable, but they see something. And then after you already show them something, you start downloading the JavaScript and you start reviving the view. And what we do is we render it again. Basically, we set up the environment again on the client. So we do unnecessary work, essentially. We render the whole page twice, once on the server and once on the client. But that's a trade-off to get that initial view really fast so that the end user feels like they have a really good experience. Another use case for it is, for example, search engine optimizations, where they're really optimized around getting that initial static payload rather than continuously monitoring the page for JavaScript execution. So that's really the main use case as I see it. There's a case to be made for having a unified code base, even for pure server-side rendering. So even if your views are just pure server-side, at least you can port your skill between the environments. But that's less of a selling point for React. It's more about the other 2 points.
The purpose of the render function is to describe how your components look at any given point in time. Give a description of how the render function works and why it's needed.
So the render function is essentially a way to say, when I first show this view, what should it look like? It's basically creating the whole view, but the view is not necessarily the lowest part of the tree. It can consist of other components that then have other render functions. So it's for any single page, you wouldn't just have one render function. You would actually have a lot of render functions, but they get executed one after another. But the point is to be able to express what the view looks like even after an update. So instead of doing an update in the traditional model and the traditional imperative model where you change the value, now you have 2 different ways of describing what the view looks like initially and what the view looks like when it's changing. You used to have something like a create function and something like an update function. But really, what you want to do is describe at any given point what does the system look like, and now you can unify the code into one thing. That helps a lot. Anytime you can unify 2 pieces of code into one, you can help solve a lot of bugs that happens because of them being slightly out of sync or because imperative updates are difficult to do. Another way to think about the render function is as a template. So it's basically what the templating or the view system would do in an MVC style framework. But the difference is that you're not limited to a subset language like a templating language is. You have the full power of JavaScript to do arbitrary logic to what you need to do. And as a company, we really think that part is really important because it allows us to always stay in the same environment and always be able to tweak and optimize and change minor parts of the views.
The focus of our conversation is React.js because this is JavaScript Week on Software Engineering Daily, but there are a few ancillary technologies to React.js that are worth discussing because of how important they are to the developer ecosystem as a whole. And those technologies are Flux and React Native. So first let's talk about Flux. Flux is the application architecture that Facebook uses for building client-side web applications. And Facebook also endorses that other people use Flux if they're going to use React.js, although it's optional. Is Flux a design pattern?
Yes, I would say so. But it's more than a design pattern. It's a design pattern in a context. So there's a lot of similar patterns that has come up before. There's also similar styles of frameworks that we've seen in other environments. So one known design pattern would be CQRS, for example, the Command Query Responsibility Segregation. That was designed from a different point of view, but a lot of the same ideas apply to Flux. But what Flux did was explain those ideas and that design pattern in the context of UIs and how you build user interfaces. So that's really what the design pattern is about. Then we also have various types of implementations that gets associated with Flux, but it's really about the design pattern and the architecture flow. It's not about any particular implementation of it.
And so the name Flux is so great because it connotes change, and this directly confronts one of the scariest parts of web development, which is that everything is changing, and we're always afraid that some element of this big architecture we're working with the browser and the server and the device, we're always worried that something is not going to keep up. What are some techniques that Flux uses to keep up with rapid changes in web development?
So I think one important aspect of that is how well decoupled Flux is from React. There's nothing really inherently built into React to support Flux. You can use Flux with another view system. You can use Flux with web components or other DOM-centric imperative APIs. But you can also use React with different programming models other than Flux and different styles of architectures. And you can also build other abstractions. We have this abstraction called Relay, which builds on the idea of Flux, but is more of a framework built on the idea of Flux together with GraphQL.
Maybe you can explain the idea of Flux and the one-way data flow.
Right. So Flux is basically, the main idea is that you don't have, for example, data binding where you declare that two fields are always going to remain the same. The way you describe your application is in terms of we call it one-way directional, but one-way in this sense is cyclic. It's a cyclic data flow. So everything starts by flushing things from the top of your application and down through the application, and then flushes back all the way back up to the top, and then that just keeps going. Right? That's the cycle. But there's one direction. It's not all the way down and then all the way back up again. It's all the way down and then start from the top, and then all the way down and start from the top.
Right, so I can elaborate on this. So the Flux documentation, it says that a unidirectional data flow should be the primary mental model for the Flux programmer. And there's this great pair of pictures that I will include in the write-up for this show. So the first picture displays that there's this flow, and it's just boxes and arrows, and there's a box that says action on it, and then there's an arrow pointing from action to dispatcher, and then an arrow pointing from there from dispatcher to store, and from store to view. And then from view, there's another arrow that points to another action. And so it's saying that this is how the cycle works. And then the view generates another action, and then from the action, you go back to the dispatcher. And so it's just this constant cycle where, essentially, I mean, my interpretation is the user has some sort of interaction with the view, and then the interaction manifests into the idea of an action.
Yes.
So okay, and very interesting. So yeah, I think this is a really useful paradigm for how to look at things. And like I said, I'll include some of that in the show notes. So let's talk some about React Native, because React Native is super interesting, and I'm not sure how heavily you guys are involved with React Native. Were you involved with the development?
Yeah, I was at the very beginning of the project. And so we found out at Facebook that when we were in the web world, like everything was fine. We had one developer like working on the features, and like he could like ship like 2 times a day and things like this. And then we moved to mobile because this is like where most of the users are and like where the best user experience is. And we dramatically, as a company, decrease in speed of iteration. And there are like three big factors for this. So the first one is the developer experience. So unfortunately, when you're working on a native platform, like you're now back into a compiled environment. And so you've got, every time you do a little change, you've got to compile the entire app, and it takes a long time. And also you've got to like compile for the first time. And at Facebook scale, like the app is really big, and it takes more than 30 minutes to do the initial compilation phase, which is extremely slow. And also, the iOS and Android APIs are still using like imperative mutative APIs that we've known like from the web and with React that is not the best developer experience. And so we had like this big developer experience issue. And the second part is now we have three code bases, one for the web, one for iOS, and one for Android. And you may think like, oh, you're just going to staff three more people and you're going to like get a 3x like developer cost, but this doesn't work like this. Now you've got communication issues, so it's more than 3x, and you've also got like some perverse issues. So for example, if you are the one that wants to drive an idea or like a prototype something, on the web world, you just did it, you just do it, you show it to your manager and you ship it. But now what you've got to do is to actually do it, but you also need to convince the other two people to actually build the exact same feature. And now it takes you to convince people, and like everything goes slower. And it also introduces some like really bad team dynamics, because now you've got like three people doing exactly the same feature. And so now you're in a world where people can compare each other's. And now, like as a human, you want to like have the best one. And so we also seen that like an entire organization, like for example, all the people working on iOS, they're trying to show that iOS is the best, and people working on the web, that web is the best. And now instead of like all the company going into the same direction with the same goals, like each sub-team has its own goal. And so what we found out is like this is a very big problem, and like the company invested in like many different projects in order to like try to solve these issues, and React Native was one of them. And so the idea of React Native is we have this generic UI library that's targeting like the DOM, but it's with the virtual DOM, like it's generic enough that it can target anything. We've seen that it can target Canvas, and we actually tried to target iOS views. So instead of rendering divs and span, we render UI views and UI label and things like this. And so this is how the project started. And it actually it was a pretty crazy project to like re-implement like a UI library on top of iOS and Android. But
yeah, and what I would say is so like kind of crazy sounding about it is I've used these things in the past that advertise themselves as being these things that will magically transform your JavaScript application into like port it to iOS and Android, and they're always false promises. Like they never work. They compile to some crappy application, or it has like just this awful web view, and it just doesn't work. So it's like it's really inspiring to see that it sounds like React Native is actually figuring it out, and maybe is the key. I mean, is a lot of the key basically this fundamental idea of the virtual DOM that is this universal view representation that you can translate from the virtual DOM to essentially any sort of view platform, whether it's Android or iOS or the web?
So I think this is one of the part, but I think part is what are your goals at the project? So most of those projects that attempt to do cross-platform, like their main goal is to be cross-platform. And so React Native, we want, like this is our second goal. Our first goal is we want to be able to deliver the absolutely best user experience on one platform. This is why we only started on iOS. And like we bet that we would be able to give a better developer experience for iOS with the same like really high quality user experience. And so we spent like a year working only on iOS, and it was really challenging. Because we were working from the web model, and we tried to get the web like be as good as native, but we failed. And Mark Zuckerberg went on stage and said like, "Oh, HTML5 is dead." Like this was the biggest mistake from Facebook to bet too much on this. And now this was an interesting thing because what we wanted with React Native is to take the best of both worlds. So native has some really good advantages. For example, like the performance is really good. And one of the reasons why the performance is good is because when you're in the native environment, you can like actually write C++ and like assembly and talk to the GPU directly. And so, for example, like image caching, like image decoding, like all of those things, right now they're implemented in the browser and they're not doing a good enough job at it. But what we found out is on iOS, if the iOS developer platform doesn't provide what we need, we can actually like rebuild like image caching and things like this, which we cannot do on the web. And so what we've done was to partner with many teams internally that are working on like really advanced iOS like user experience. For example, like the Paper team built like some crazy good like user experience. The iOS feed team built like some really performant like feed that's powering like, I don't know, like maybe 1 billion people. And like this was like the goal is to get the same user experience. But what
yeah. So, sorry to interrupt you here, but this is something that's so interesting to me because it seems like it's a theme that's developing. Like yesterday, I had a conversation with a guy at Microsoft about TypeScript, and he was talking about essentially all these alliances. Like one was like there's an alliance between Microsoft and Google because they have synergies on TypeScript and Angular, and we also had a conversation about WebAssembly, which is essentially a teaming up of people from Firefox, people from Apple, and so on. And it's interesting because it seems like maybe we're in this age of tons of collaboration.
Yeah. To me, like you cannot like have the best platform and like have the best library without innovation and without like collaboration. And so to me, like React Native is all about finding the best ideas from like all of those places, like from iOS, from Android, from web, and actually compare them and evaluate the trade-off of all of those and find the best part. So this is what we've been trying to do with the project.
And so what is the long-range view? Where is React Native going?
So I said like we were focusing on 3 big things, which are like developer experience, and we think like we've got a good developer experience, but we want it to be better. The second one is cross-platform, and like we're going to open source the Android version of React Native, and right now we've got like a separate implementation for iOS, for Android, and for the web. But ultimately, what we would like to do is to unify those like low-level implementation. And maybe one crazy idea we have is talk directly to the GPU. So we have a React that outputs a virtual DOM, and then we send this directly to the GPU, and we bypass like all of this stack that's proprietary and build a new stack that's like designed for React. And the third like big focus that we're going to work on is shipping updates. So right now we've got to be on the schedule for iOS and like the Play Store review. But what we want to be able to do is to have the same release schedule at the web, like we will be able to push like 3 times a day. So this is like the big, like those are like the long-term goals of the React Native. And we know that the project right now like is good, but like this is not where we want to go, and we're in for the long run. Like we're deeply committed to it, and we're starting to port major features inside of the Facebook app, And yeah.
So really, this for React in general is that we're starting to see more and more of these output modes. So that we talk about web, we talk about Android, we talk about we have canvas drawing, we talk about iOS. But a lot of companies are doing very similar things. So Netflix, for example, are targeting TVs using React, and they have their another view layer. So we want to make it easier to get React into other platforms that we are not specifically focusing on. There's other companies like gaming companies that are using React to build their UIs for games, for example. So integrating with game engines is a big priority for them, or even running React on consoles to build the UIs for gaming consoles. So we're trying to make it more decoupled from the DOM and just keep going with this idea of React as a programming model.
This stuff is all really exciting. I want to get some insight into what the development process of React is like, because this is a super ambitious project, and I'm really interested in terms of how you guys manage tasks, how the people are managed, how people interact. Could you give me some insight into that?
So we're not that good at tasks, but I think the most important part is sort of getting people on board with the idea and where we're going. Sometimes we struggle with that. For example, selling this idea to iOS developers from the beginning, that you don't actually have to do it this way. There's another way to do it. If you're invested in your entire career in iOS, then that's not an easy sell. So the first thing you have to do is really talk to people and respect their skills levels and respect their concerns, so that they're on board with the idea you have. But then what is really important for our development structure at Facebook is that we try not to open source something just because we think it might be a good idea. We open source more to get early feedback, but we really focus on building something for a real product. So we both work on a general team called product infrastructure. And the role of our team is to figure out what the problem is in the current system of our development experience, fix that, and then try to convince people to use it. So to fix that, we have to understand what the problem is. So we focus a lot on embedding and collaborating with a single team. We build these frameworks to solve a specific product, a specific application. So the first two for React Native, for example, was the groups, the standalone Facebook Groups app, and then the Facebook Ads Manager for mobile devices was the second one. And that collaboration, that tight collaboration with a single team, is really important for us to be able to understand the needs of the users of this framework, and not be distracted by trying to solve everyone's use case all at once. But then the other part is we don't tell anyone at Facebook to use this. We have to convince them that they want to adopt it. So that ties into the whole idea that you need to be able to provide a real value that solves someone's problems, and they need to be excited about it. Sometimes that's about convincing and like explaining why it is, and sometimes that is about listening and seeing that you're not solving the problem that they're actually having, and you might want to course direct based on that.
Okay, cool. So I want to close off because we only got a couple minutes left. You guys can answer this in as few or as many words as you like. I want to ask both of you, what excites you the most about the web development world that we haven't talked about yet?
When you say web development world, what do you mean more specifically?
However you want to interpret it.
So I think for me, like the best part about the web is I can just write some code, like put it on my server, and like everyone can see it, and I can send the URL and everyone can see it like instantly. And so this is like the best way to develop. Like anytime I work on something and I cannot show it to people, like I get demoralized and I don't work on it. So my development workflow is more like I code something and I show it to someone, I code something and I show it to someone. And this is one thing that is really missing in the native world, is the only way to show someone what you've been working on is to submit app to the App Store. But if it's just a prototype, you don't want to submit an app. And like this is
that's a good point. I really like that.
Yeah, this is very frustrating to me.
Yeah, and the thing that I like about the web is that it's slow moving, and there's a lot of standards and a lot of opinions that go into it. But and there's sometimes that leads to flaws, and it leads to bloat, because you have a lot of people wanting their opinions in there. But there's always a subset of the web that is really, really good. And it's really good because there's a lot of people, a lot of eyes on it. There's a lot of people that influence the web. That's different from something that comes out of a single company or a single project. Is that there's a lot more collaboration and a lot more people from different environments and different backgrounds that all have different ideas, and sometimes that leads to bloat. Sometimes it's weird APIs. Sometimes, but it's a melting pot, and within that, there's like something really beautiful in the subset.
That's great. Well, that's a great place to finish. Sebastian and Christopher, thank you so much for taking the time to come on to Software Engineering Daily. I'm a big fan of what you guys are working on, and keep it up.